Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you another example related to finding the marginal density for random variable x and y when they are actually continuous random variables. When x and y are continuous random variables, you can break them apart by considering the process of integration. So you will integrate the joint density with respect to y if you want to find the marginal density for x. So if you want x, you will integrate with respect to y. And if you are interested to find the marginal distribution for y, what you have to do is you have to integrate this joint density with respect to x. So if you want y, you will integrate it with respect to x, and if you want x, you will integrate that with respect to y. Okay. In the previous video, we have looked at this example of discrete case. All right, and so in this video, I'm going to continue with the continuous case. So here what we've got is the joint probability density, which means it is a function that describes x and y together. So here is a function that depends on both x and y. And basically these are the limits for random variable x, and this is the limits for random variable y. And we're going to find the marginal densities of x and y, and the answers are given right here, and I'm just going to show you how can we obtain such answers. All right, we're going to start off with finding gx, and according to the formula, what we have to do is we have to integrate this function right here with respect to y. Okay, and in this case we can see that the limit of y is from 0 and 1. So here we are going to plug in the limits, and then I'm just going to write down what's the joint probability density, and it is just 2/3. I'm just going to take out straight away. So 2/3 here is a constant, so I'm just going to take it outside. So 2/3, and here we have x plus 2y dy. Now I'm going to integrate this. So what we have is x is considered as a constant because it doesn't depend on y, therefore our result is xy. And for this one is if you integrate this, you will get 2y squared over 2, and you can take the limit as 1 and 0. Now I'm just going to substitute the values here. So what we have is x1 plus, this one can be cancelled out, 1 squared, and if you substitute 0 into this, the result is going to be 0. So really we don't have to do anything much, and the answer is going to be 2/3 x plus 1. Okay, and therefore this result here is applied when limit x is between 0 and 1, and we can write it in an elegant manner using this notation, where the result here is given for x between 0 and 1, and then you will get 0 as well. I hope you can see that intuitively it makes sense. If you want to find gx, what is the meaning of gx? It means a function that only depends on x. Okay, so if it depends on x, we need to get rid of all the y's in the original joint probability density. So therefore, if we need to get rid of y, we need to integrate with respect to y, so that when we substitute the values of y, we can eliminate the alphabet y from the whole thing. So what we have is we're going to have the end result of this is just going to depend on x. So the end result is going to depend on x because when you integrate with respect to y, you will be able to substitute the values of these numbers here into y, and by doing that you eliminate y from the original joint probability density, and therefore you get an expression here that only has x in it. Okay. Right, now let's move on to finding the marginal density for y. Okay, so now we're going to find what's the marginal density for y, and we need to do integration, and we're going to integrate the idea is we're going to integrate the joint probability density, which is fxy, and we're going to do it with respect to x. Therefore, the limit that we have to plug into here are the ones associated with x, and the limits are 0 and 1. Okay. Next, this is the joint probability density. You can see 2 over 3 is a constant, so I'm just going to take it out straight away right here, and here I'm left with x plus 2y, and we're going to do it to integrate that function with respect to x. And the result is going to be, so if you integrate this, you will get x squared over 2. This one is considered as a constant because there is nothing related to x right here. So the result of this is going to be 2yx and 1 and 0. So now we're going to substitute the value of 1 and 0 into x. And I hope you can see that by doing it, we will eliminate x. So we're going to get rid of x out of this original joint probability density. And so at the end of it, we will have a result that only depends on y. That means the function here we only has y in it. Okay, so here we have 2 over 3. Now substitute 1 into x, you get 1 over 2 plus 2y. And if you substitute 0 into this, the results are going to be 0, so we really don't have to do anything about it. Okay, so finally we have so what we have is what we can do is you get 2 over 3. So here we have 1 over 2 plus 2y. Okay, and maybe if you want to get rid of this, what you can do is you can have 2 over 3. This is 2, 1 plus 4y. Yep. And you can cancel out 2 and 2. And finally, you have 1 over 3, 1 plus 4y. And this one is applicable for y between 0 and 1. So this one is for 0, y between 0 and 1. And so you can write down the final answer as such. Okay. So I hope that now it makes sense to you why when we are looking to find the marginal distribution for y, so we have to integrate with respect to x. Okay, because what it means really, so when you have this function here, it means this function we only has y, or we only depend on y. So in order to get rid of this x, okay, we need to get rid of x. We need to integrate this function with respect to x, and by substituting the values into x, then x will be eliminated and you will be left with just an expression here, that only has y in it. Okay, so therefore this is what we call the marginal density for y. Okay, I think that's all for now. Thank you very much for watching. I'll see you in the next video.